Assalamu alaikum warahmatullahi wabarakatuh. Welcome back to the Signals Assistant course. And again, this is Signals, the model talking about signals, and we're talking about now the signals operation. Again, this is a central concept on this course and how students could understand it and work with it easily. Now, in the last lecture, we were talking about signals transformation. So each signal could be transformed from signal A to signal P. And then after we have reached to a certain transformation within the signal, we could do some operation between signals. So we will have signal A and signal B, and then I will do some operation between them. The first type of operation is the summation. So I just simply can sum them up as shown over here. So this is the result of the signals where we add two signals to each other. So each one could be transformed somehow, like from signal A all the way to signal A prime, and the same is happening here. So signal B all the way we reach to signal B prime. And then the second type of transformation signal operation is the product. So we have signal A and we just multiply them by signal B. So this is the second type of signal operation, and it happens between two different signals. Now, to do this, there are some steps that can ease the way to do it. So first of all, we have to identify or define a generic function for the signal over time periods. So this is the signal, like signal A or B or whatever. Then we have just to make sure that we understand the definition of this signal on each and every period of time. And then repeat this again for the second period of the time all the way until we cover every single period over the time. So this is the time axis, the horizontal time axis, and then we will define the function based on these periods. So in period number 1, in period number 2, 3, etc. So let's say this is period number 1, which is this one, and this is period number 2, which is shown here. So after we define them clearly, then we will do the operation over each period. So we will go to the first period here and see what is this is like signal A, and we do the same for signal B, and then we will define these periods and go ahead. Then find for each different period what is do the operation. Like if it is addition, then we do A at period 1 plus B at period 1 and find out what is the result. Do it again for the second one, A at period 2 plus B at period 2, and a similar way till we finish all different periods. Make sure that you connect the starting and ending points. So for each period there is a starting point and there is an ending point. So this is start and this is end. So make sure that when you do the summation, you calculate in particular what is the starting point, where it does it start and where it does end. So then we could find out the connection between different periods. Number 4, then estimate the shape of the curve between each 2 points. So whether it is straight line or is it like a constant or a curve with second degree or whatever different degrees. then we're done. So this is what you're supposed to do when you are doing signals operation, if it is addition or multiplication or any different type of operation. So let's take one example, the product of these two signals. So this is signal for instance A, and this is signal B, and we want to calculate x, which is equal to xa times xb. So this would be somehow here. So this is t. So what I will define is this is the period that we're talking about, t1, and this is the starting point and ending point. So in the first region, there is a 0 in the first in signal A. 0 multiplied by any different constant, it will give you like 0. So this is what we are talking about. So at this particular point, we have to define that this is from left side approaching, it will be equal to 0, and from right side we have to find out what is the value of the function here. Let's say that this value is 5. So, and this is 1. So 5 times 1 will be 5. So this will be the value of this signal at just the connection. Then we will do try to estimate. So this is 1 times this function. It will come all the way exactly the same at this point. And then just we want to define what is the number here. Let's say it is 6. So we will just try to draw an estimate of this function to reach to this site. So here will be again 6, and this is 5. And then afterward, this is period 1, 2, 3. So at period 3, it is clearly that this is 0 times this one, it will be equal to 0. Okay. So after that, we just came back to the 0. So for this signal, so xa will be equal to 1. This is the definition for t greater than t naught and smaller than t1, and it will be equal 0 otherwise. So this one we cannot define it because we don't have the function of this curve. Here we can define the constants if we got it, but just let's say that this is regardless because it will be multiplied by 0, so it doesn't matter what is this definition. So a signal that has a result, so this is our results, has both left-sided and right-sided is to be finite duration. So now we got a result of this signal which is not having a value other than 0 from left side and right side, and this is what we call it finite duration. So this signal exists only in this finite duration. Okay, so now we're talking about some product of multiple signals. Let's discuss the properties. In particular, I just want to come across the periodicity and even odd. So whether it is periodic or aperiodic, and whether it is even odd signals, it will keep maintaining that properties or it will lose it. So first, if we talk about the periodicity, so let's say that this is with a period A, and this is a signal periodic with a period B. So if we add these two signals together and we want to know whether this result, whether it is periodic or aperiodic, if we test this and if we try to understand it, then we will find out that it will be periodic only if the ratio between the two periods of the individual component is a rational number. So if it is rational number, then it will be periodic, otherwise it will not be periodic. So this is the condition. And what about the product? So let's think about it. So if we do have like a signal, and this is like repeating in a certain range or a certain way, and then we have another signal which is repeating in a different pattern. So let's consider this is TA, and this would be the TB. So this will be a TB signal, and so on. So this is the TB period. So if we multiply both of them, we would get like this is let's say the high is 1 and the low is 0, both the same. So we will have this one 0 and this one again, then this is will be neglected, then again this one and this one will be the same. So somehow it will repeat itself, but this would happen only if this condition is valid. So again, we have to consider that TA over TB is rational number. Then also the product will be valid for this given example. Now let's consider the property of even odd. So if this signals the component has properties of even or of odd functions, then we would just test whether the result will be even or odd. So let's consider that if we do have this simple even function, so this is xa, and this is the another even function, which is this guy. So let's consider if we try to add them together. So since this will be representing exactly the same shape of this, and this will represent exactly the same shape of this, so the addition of this side will have exactly the same effect of the addition of this side. So I think it will come to a way of certain shape which is still, it holds the even function. So if both function is even, then we will come to an even function, and if both are odd, it will come again to the odd function. So what about if it was mixed? So let's try to use this example. So if we try to use this example, so these two will add in a way which is totally different than these two. That's why, so adding an odd function to an even function will have certain different effects from both sides. So this will not result in neither even or odd functions. Now, what about the product? I will leave you to think. I'll leave you a space to think about it outside this lecture. Thank you for your attention, and see you in the next lecture.